Good afternoon, everyone. Welcome to your GitLab session under the mentorship of Mr. Vimal Daga. I'm sure you all having a smooth journey and you all are practicing whatever is being taught to you as well by Vimal Daga, sir. In case if you're facing any challenges, technically or management-wise, you can please put across your challenges or your questions right now in the chat box. We will ensure that the technical volunteers would be there to help you. Second thing is like the access for the learning portal has been given to all of you for the GitLab. In case if someone is still facing a challenge in getting the access for the GitLab sessions to revise the sessions which happened earlier on the last weekends or referring to the reference material or whatever manner it is, do let us know. That's the reason I'm here for next 5 to 7 minutes, just to ensure that in case if you're facing any management related issues, we are there to help you. So the chat box is open. If any one of y'all are facing anything, please let me know. Yes, Sahil, you can please tell me what is it? The chat box is open for everyone. In case of any challenges, please share it right here. We'll be there to help you all. Vimal sir will start the session in the next 5 to 7 minutes. Ma'am, is it necessary for all 2.0 students to be registered for MySQL certification? Yes, it is. Yes, it is. It's then when you receive your MySQL certificate. Anyone having any queries respect to the access, the learning portal, reference material, any other help which you all are looking for, can please put it across in the chat box. Ma'am, system designing pricing is the same for all students also. Prashant, yes, it is the same currently. This is the first ever 100% practical system design course which has been designed in the entire world. If you see this content, so just giving a brief to everyone, there are around 104 institutes, organizations, universities across the globe who are offering system design as a program. If you take the content of all the 104 institutes, and if you compare with the content which Mr. Vimal Daga sir is offering, still the content which we are giving is much more than what they are offering. At the same time, the pricing at which system design happens is around 3 lakh, 5 lakh, 10 lakh. It depends upon universities to universities, colleges to colleges, and institutes to institutes. We have priced this at the bare minimum cost which we could, considering that maximum of them can get this benefit of learning from Vimal Daga sir. Over and above, there is one exclusivity, okay? None of the organizations are able to offer system design in the practical manner. The only reason is because there's no one in the world who can offer a single mentor can give you system design, because there are very few countable people on this globe who know so many technologies and who can integrate all of these technologies as well. Correct? So Vimal Daga sir is one amongst them who knows all these technologies, can integrate, and can be the one who will be a mentor for the complete system design program 100%. That is the reason. Ma'am, EMI option hai kya? Prashant, please get in touch with my team. I'm sure they might have something for you. MySQL is a part of our 2.0 program. If I talk about giving you as a training, okay, but if you register, then the certificate process goes through the free program process. So that is the reason. So basically we gave it to you all. We gave MySQL to our 2.0 learners. It was a giveaway. No doubt it was a free program. So for that, please follow the process. Is MySQL advanced part of EX358? No, the advance of MySQL, which is MariaDB, I'm not very sure, but I'll still let you know. I will drop a message in 358 group. I would request every one of you all to please raise your queries with respect to this program, specifically GitLab. It would be easier for me to address. I would be coming in all the programs one after the another to guide you all with your questions, so that the other members of this group doesn't feel like what kind of questions am I addressing to. How many sessions of left for GitLab? Vimal Daga sir will be announcing that. I don't have any clue about the technical delivery part. Only Vimal Daga sir would be considering that part. Ma'am, what course is system design? So system design is basically designing your uh, large scale, real, uh, system architect. It's one of the most popular role which people in the IT domain look for. And the packages are also very high. The demand is very high for system design people. So basically it's as simple as that. Let me explain you in a very bare basic concepts. Knowing each and everything about a product is something like a system design program. Every implementation, right from front end to back end to cloud to storage, anything and everything to automation is a part of it. I want to learn operating system and networking concepts in deep from Vimal sir. Rajan, I would request you to get in touch with my team members. They will help you with whatever they have currently available in the self-paced learning mode. Okay. Do we have any course on Istio or Helm? No, we don't have, but yeah, we are planning to come up with one, Vijayendra, because we have received ample of queries for Istio or Helm. But yes, let's see. Ma'am, can you do timings in the morning for your courses? Say we cannot. The timings would be the way it has been designed. There are ample of things going on at the back end. List of courses offering where we can find our hash 13 website is getting ready, where you'll find all the list of the courses which are available, be it self-paced or be it the upcoming live trainings. But I think you'll have to wait for the same. By that time, whichever is available in this week, many self-paced learning programs will be available, like CKD, which is Kubernetes, Ansible, Terraform, Advanced Git and GitHub. There are many programs which are coming up for the self-paced mode, wherein you can just undergo the learning at your own convenience. So we'll be doing that. Sure, Gyanraj, I'll definitely communicate this Knative to Vimal Daga, sir. In case if we have something coming up, we'll keep you updated. Vijendra, you would like to buy Ansible and Kubernetes. Both the courses would be available in next 2 to 3 days in the self-paced learning mode. So once it is available, there will be an update in your respective WhatsApp groups. Please look into the same. My pleasure, Gyanraj. Thank you. Need to learn data structure algorithm. Data structure and algorithm, DSA, Vimal Daga sir does it only for the Earth learners. So, and for Earth, the Earth is open only for the engineering students. It is currently not open for professionals. RHCA, is it similar for networking course? Rajan, it is RHCSA. RHCSA and 358. These two are the programs from Red Hat, which are very similar to your entire detailed networking, including your servers, your protocols, and everything. RHCSA and RH358. These two are the programs which you can address with reference to my team members. They'll be able to help you. No, Ashish, we'll currently not start security on 16th. It might get postponed for a week or two because we'll complete 358 first, then we will start security, which is RH415. 415 will start after RH358 gets completed. Linux basic and advanced course for embedded system, no, we don't offer this. Can I get self-learning Kubernetes and Ansible? Yes, Gyanraj, in the coming week, we're opening this for for anyone to do it on the self-learning mode. The registrations would be open. You can do that. Linux basic course, yes, we do have industry relevant 16 hours of Linux program, which will also be open in this week itself for the self-paced learning. Perfect. I think good to go. So we do have Vimal Daga sir here to take it forward. And in case if anyone has any queries, we'll address it in the next session, which happens tomorrow for GitLab. In case of any management related queries are there which you want me to address. Perfect. Thank you so much, each one of you all. Over to you, Vimal sir. Thank you.
Hey guys, welcome back, and let's continue with the next part. So last classes, guys, we have discussed a lot of thing about GitLab, right? So let's continue, and multiple things I have is there in my mind to plan for today's class, right? So this is the GitLab portal, and before we start the next concept, let me very quickly launch a new project. After you guys logging with the GitLab, you guys know, right? This is what the screen you see after login, where where you can see your project, and these two project guys we have created in the last two classes. So I would like to create a new project. We can do some more things and a lot of new things today. So let me create a new project. Okay. And here the project would be a blank project. I would like to start from. Let me give a project name. Let's say third project, something, this name I'm giving here, and make this project public and private. Doesn't a big challenge, but let me go for private only. Okay. So I'm using this project as a private project, and let me create the project, right? So in the GitLab, guys, you know, when you create a project, so every project has the entire own set of tools. So this project, they have their own what I say, your so after this project is created, you have your own entire repository over here where you create a project. Even though, guys, I forgot to enable one option here, so they're asking me to create the repository. So let me go back. Let me delete this project, because when you create the project, that time you have to initialize the repository the way you do in GitHub. But if you forget to initialize, you can create your own repository, like upload from your local system. That's what the similar command that you see in GitHub also. But here I forgot to initialize my repository. Either I can add from here or while creating the new project, you can that time you can initialize in the down there's option to initialize the repository. I forgot that time. That's why they are not showing you any repository here. Okay, so because the repository is empty, but how to initialize either at the time of creating the project, you can initialize, or you can add the README file to initialize this. Okay, so let me add the one new README file. I said this is test, just nothing very special, and let me commit this. So as soon as you create the README file, your project automatically or repository in this project automatically initialized. So if you go back to your project, now your repository has been initialized. You can see the repository name. So multiple way you can initialize the repository. It is almost the same what you see in your GitHub also. Okay, so now in one project you have your repositories, you have your entire CI/CD pipeline, that what we had discussed in last class in very detail. You in the same project, you can do your monitoring, you can find out your analytics. All right, you can manage your container registry without going to Docker Hub. You can manage your own container registry, and that's more thing you can do over here. But this, because this is the GitLab training, we are more focusing on the CI/CD part. Okay, so I want to emphasize more time on the CI/CD perspective. So in this project, whatever the code you have and you want to do a CI/CD on the code, you can do it. But for this, you need a runners. Okay, so what is runner? In my last class, I told you already about the runner. So if you see, go to settings and setting, if you go to CI/CD, here you can see the runners we have in this particular project. So by default, some runner is given by your GitLab. This called shared runner. At this point in time, I have around 43 runner available. Okay. And some runner we can add by ourselves. That is called a specific runner running somewhere, maybe in your local computer. So maybe you can run your own local machine, either Linux and Windows, okay, or maybe Mac in your local system, maybe a virtual machine, or maybe directly in laptop, and you can connect these computers, okay, or connect this virtual machine to work as a worker node or the slave node or as the runner, okay. And what the process of connecting the runner I showed you in my last class already. So it doesn't matter wherever the system would be, you should require the network connectivity, okay, to make your computer as a runner, okay. So this concept I explained to you, and we already connected one of the runner in my last class. In my case, I show you the runner running in the AWS cloud, but it would be anywhere, any cloud, the runner can be run, or in any system runner can be run. Only thing is between the GitLab and your computer should have a network connectivity. Okay. So what I'm going to do today, okay, because the base upon my requirement and the today's practical, I'm going to have one GitLab, okay, and in GitLab I have already created a project. I've already created a project. Okay, so GitLab would be like my master computer, okay, or it is mostly known as the manager computers, okay. And what I'm going to do, I'm going to connect two worker nodes or two slave node, and in this case it is known as runners. Now it is your choice where this runner is running, okay. This runner may be a shared runner, or this runner will be your runner you take from somewhere. So I would like to connect this runner to the GitLab and this runner also to the GitLab. Why two runner? Because this is what some of the practical we want to perform in today's class, right? Okay, so I'm going to connect two runners, and to make the things this practical established and to be completed very quickly, because this is what we have seen in my last class already. So what I'm going to do, I'm going to set up this two runner in my AWS cloud. Okay, so I'm going to launch two virtual machines in the AWS cloud. Both the virtual machine, let me take the Amazon Linux, but you can take any of the operating system. So why I want to connect two runners? Because something we will do today, right, on this setup. So we have one manager and two worker node, or two runner or two slave node to do our CI/CD. And I'm going to build the entire continuous integration part and the continuous deployment or the delivery part today. Okay. So what we do, even though guys, today I'm going to show you about this part also, right, about container registry, okay, and lots of Docker respective thing we will see today. So we are going to create a pipeline where my Docker image build dynamically. We will use a Docker image. We will deploy the Docker images on a custom code. Lots of things related to this topic we will discuss. So I'll explain you every bit step by step. Okay, but let's have this setup ready. So I'm going to launch two instances in the AWS cloud. So in my case, I'm going to launch two instances of Amazon Linux. Okay, two instances, and that's all. This would be my GitLab runner for Docker. Something related Dockers we are going to do today. So I'm just giving this name. Okay, firewall I'm disable all for means there's everybody's allowed, and launch. That's all. So two computer I launch. And in both the computers, I'm going to launch the the runner here, right? So how to do, you guys know very quickly, we'll see. So if you say GitLab, I want to set up the runner or install the runner. Okay, so there's a one link we've seen already in my last class. So we can run the runner in any of the operating system. Now this operating system would be running in your local computer on the cloud. It doesn't matter. Even though we can run the run inside Kubernetes, if you know the Kubernetes pod, we can run there. We can run the runner inside the Docker container. We can run anywhere. But in my case, my runner is running on Windows or Mac or Linux. In our case, it is running on Linux, but it can run in Docker and Kubernetes also. Okay, so let me use the Linux operating system. And Linux, in my case, my Linux operating system is Amazon. It is more like a Red Hat Linux. So we will use this link to download the software. Okay, so let me use this link to download the software in this OS. So I'm running with these two operating system, right? Let me change this name. This OS I'm going to use for CI perspective today. What is CI? Continuous integration perspective. And this OS I'm going to use for CD perspectives, for continuous deployment or the continuous delivery use cases. What are these? I will explain to you. But let me set up the runner for this. Okay, let me also start GitLab. So only these two names are gonna come up. So let me install the runner in this computer. Connect, and from here we get that, right? So this computer, I am going to connect this computer to my GitLab so I can do something on this computer with the GitLab pipeline code. Okay, first of all, I would like to run this command. Best to download this software. So this is the GitLab runner software, and same I'm going to download other computer also. Let me do it step by step, and after this I can install the software. So that's all. So there's a two commands we run, and then we have to execute it and do these other steps we have to perform, right? So, and that's what we have done in the last class. Again, this will be a quick revision. So this software has been downloaded. Let me install the software. GitLab runner software has been installed. The minimum requirement for the software, I need Git software to be installed. So let me install Git software with the yum command. Okay, there's a dependency they have, and then we will install the software. After installing the software, we can this part is done. Software installation is done. So this is step by step. Then we will make this command of git runner executable. Okay, executable. So there might be some warning come up. Okay, maybe some of this software might looking some kind of Docker requirement, some use cases, not all the use cases we need. So we can skip this warning, and let me make this command executable. This command is not there. It's not there. Why so? The software has been installed right already. Okay, it's been installed already. So 1 minute. Let me run this software should be installed. Let me create the GitLab runner. This has been already done. Let me execute this. Best. In it already exists. Actually, I think this software what I installed that will done this step already with us, right, for us. Okay, so the software that I installed that has intense setting, they have done all this stuff for us. So that might be one of the reasons this was giving the error. Okay, and let me quickly run my GitLab runner over here. So best, and the GitLab runner is being started. Okay, so remaining step, guys, this software that you installed, they have done for you. Okay. So they have done for us, right? But technically it's been done. One last thing that you have to do, start part has been done. 1 minute. So one thing is missing here when you start. Even though, guys, when this maybe is better document, I come to this page where it's done in my last class. So the runner instructions and the Linux instruction, this is the better instructions to perform, and this is what we have done. And finally, guys, we have to register, right? So let me register. I think till here we have done already. Okay, and this is the last command I'm going to type. Okay, so to register my runner with the Git lab master, right? And for this I need token, and token I can get from here. So as a quick revision, guys, somewhat we have discussed in my last class. So they said, you want to connect to GitLab? I say yes. This is a token. Yeah, yes. Okay, this is the here describe enter description for the runner. Let me go for the by default host name. Okay. So can you give the tag? Tag is very important. I told you in my last class. So let's say this tag I use, this is for CI. Just a tag name I was giving here, or maybe give some more tag. This is for build, or let me give the name of my build. Or let me give one more tag of my Linux OS. So multiple tag you can give here. You know the use of tag I showed in my last class. Okay. Any not nothing for maintenance. And when the GitLab will connect to this runner, okay. So guys, you guys know in the GitLab, you have to write a code. There's called pipeline as a code. And the code, we write a script keyword. And you write the command in the front of the script. So this command is going to run in this runner. So who is going to run this command? You're going to run this command with a shell. It's called Linux shell. Or this run is based on Windows. You have to run this command will run by PowerShell. Or maybe your runner maybe directly Docker or the Kubernetes. So we would like to run the command directly inside the Docker. Let's go Docker respective, commands you want to run. So that's what they're talking about. Who going to execute Kubernetes, Docker, Shell, PowerShell, whatever they support here. Okay. So in this case, I would like to run with the shell executors. That's all. Now this guy has been successfully connected. You can see GitLab status, if the status command is available here. So now my GitLab runner is running. Okay, and now if you search in this particular your third project, because every project will have their own runners, you can find one more runner. One new runner has been connected with us. See here, one new runner working fine. Let me add one more runner, then we will do the remaining practicals for today. So I'm going to take one more runner. In my case, this is this instance. So I'm going to add one more runner. This runner I think is been connected. Let me take this as extra runner, next runner. Okay. And to do the settings, again, same thing. I'm going to run the same command. Better I'm going to guys following this particular document. Which one? This document. Okay, here they show me the options to connect. And let me copy this entire list of commands and go here. Okay. So after this install, everything will be done. Maybe this might fail because there's a one requirement. We need a git command in the system. What's the minimum requirement for the system? So they might fail. So let me my have git installed. And 1 minute, let me check this is the same system, not right. GitLab, 1 minute. GitLab. So guys, I'm not focusing much on this topic because this part we have discussed already in the last classes. Okay. Only thing I'm going to register this node. Right now, this node is 190. The rest node that I registered already in my GitLab is actually this is what I already registered. Actually, this is what they're giving this warning, right? So this was the node I already registered. Let me go back to this one. This is a different node. I don't know. This is I want to connect, right? 90 is already been registered. Right? So I think I did wrong one. So let me again connect. Okay. So let me do the same steps. Login. Sudo su happen. I am going to install the Git first because the minimum requirement for node to be connect is the Git software to be installed, and otherwise the remaining command would exactly the same. Let me copy this command and let me paste over here. Okay, so guys, what we are going to do. So this command has been run successfully, and this command runs successfully. This command failed. They run this command already. This setup is done. GitLab runner command is not available. Now it is working, but they fail. Why they fail? 1 minute. Status, let me check. Because maybe it's not been yet connected. Let me connect to the GitLab. My token would be to connect is this one. This one. Best. The command is not available, right? Let me remove the sudo. I don't need this. Enter this one. Tag name. Let's say this is for CD part. So one of the tag I'm going to use. This is for I can say for production is one of the tag I would like to use, or maybe this is final Linux. I'm just randomly giving the tag here, but this tag is very useful when we create a pipeline as a code. Nothing, and again shell. So it's been connected. Now if you're on the GitLab status, everything status is not failed, but it's not working. They have to start the services. Service will fail. I don't know which steps they miss. Okay, service should let me restart. Which step they miss? I don't know. So maybe let me run this command first. This been done. Let me run this command also. So let me restart services. Now working fine, right? Some of the stuff I think is missed in the last go, right? So yeah, technically to run this command step by step, or because I already log in with the root account, you don't need to use sudo. That might be some of the part might not working, but now it's working fine, right? So two worker node is been connected. This was the quick revision because I already explained you this concept very detailed in my last class. So now we have two runner running. Everybody has their different computers and different tag we use for some purpose. So we have some runner. We have some runner We specify, we have some shared runner, sometime we might use this also. Now, what I want to do today, okay, based on this setup. Now, what I want to do today is something like this. We are going to write a code in our workstation. Let's say we are the developers, okay, and we're going to write a code for creating a web app. Now, it is your choice. You want to create a code in which language, PHP, Node. Today, I'm going to write a code in Python, just to give a different flavor. But conceptual wise, conceptual wise, you use Node, Python, doesn't matter, right? But I'm going to write a code for creating a web app in Python using a Python framework called Flask. Or maybe you can use Django also. Okay, and this code I'm going to upload in the repository. Which repository? This is what the repository we have in our project. This repository over here. In this repository. Right now, we don't have any Python code in the repository. Okay. After we upload the code in the repository, okay, or we can also directly create the code here also. Same thing, right? So you guys, you know how to upload with the git push command. So we will we somehow put the code in the push the code in the repository. Now, what I want, as soon as the code push in the repository or create in the repository, I want one CI pipeline will run. What is CI? You guys know. It's called continuous integration part. Okay. So what I want, the code that I have, let's say my code name is called app.py is my code name when I write my web app for the Python or in the Python language. So what I want, my CI pipeline or content integration pipeline will get this code, download this code from the repository. Okay. And they create one custom Docker image. Custom Docker image. Okay. What this image contain? This image contain one basic Linux operating system. Image contain Python interpreter. The image contain Python library called Flask, is a web application library for the Python, and plus they contain this code. Everything will be pegged inside one image in this Docker image. Okay, so based on this code, okay, my CI will dynamically create this image and store somewhere. Where to store, we'll discuss. Okay, so this is one part I want to do. Again, this is known as build part. I want this image to be built. Okay, and after this image built, we want to store this image in some centralized repository. So after this image built, I want to store this image. You can think of this image like a software. This image like an artifact. You can think in this way. Okay, I would make it think like as one kind of final software. It is like image, but you can think it's like a final artifact. Whenever you build anything, you create anything, especially in CI world, like a software, maybe program file, or maybe image, they are normally known as artifact. So I want this image or artifact to be stored in the centralized storage. And any image or the container image, especially let's say create from Docker, we need some kind of centralized repository. They are also known as registry. So I want some centralized container or the Docker registry to store the images. So store the image. To your choice, you would like to use Docker Hub for this. That's what we mostly use to upload the image and store the image over here. Or instead we go for third-party tool. We already have a dedicated private container registry in our project that is called this one. Where is this one? Over here. So if you see here, this is our private registry for this project. So you think your image is very critical, contains some sensitive data. So the best place to store your container image inside your GitLab, inside your per project. Okay, so we can control the security very well in all the forms. Okay, so here I know I don't have any image here, but I will push the image over here. That is your choice. You want to push here, you want to push here, you want to push in other registry like Amazon or Azure container registry. That will be your choice. But my plan is to push over here. Okay. So in the CI part, 3 things I am going to do. One, I would like to download my code from the repository. By chance, the repository is there only, but internally they will download. So download the code from here. Okay. Second step, I want my, based on this code, my new image will be created. Okay. A new image will be created because every time a code change, I want to create a new image because new image will contain new code. And third requirement would be I want this code to be stored in the container registry. This is the continuous integration part. Every time code upload, new code come, this step will be automatically performed. Okay. But after this step has been done, okay, what you want to do, then you will want to, why you create an image or Docker image and why you store centralized, so that your other team, okay, your operations team in the company or the team belongs to production in the company, what they do, they have their own dedicated servers. These are the production computers, for example. Okay, and these are the computer where everybody publicly from the internet connected on the IP address. Maybe this guys will have a public IP connected here. Okay, so what my operations team or the productions team were looking for, whatever the new image come up in the container registry, they will pull this image and send to this computer. They will pull and send this image to the here we are pushing it, the image, and after the image be pushed to the container registry, we want from somebody from the operations team, okay, they will pull the image and copy here. And because this is the container image, or let's say the Docker image, after Docker image sent to this computer, okay, so from the image, what can you do? You can launch the operating system that is called container. You can launch the container. Guys, I believe everybody know about the Dockers till now, and we have shared multiple basic videos of the Docker. So I think this is the very basic concepts and the terms you know: Docker images, container images, containers, all the things. So I'm going to use this term very frequently today because they're very basic terms of container Docker and a way that I believe you guys know about Dockers. Okay, or the containers. Okay, so now what I want somebody maybe from a different team, they're going to do this step number 4. They will pull and download this image stored in this computer, and then they will do the step number 5. They'll launch the container. As soon as the container launch, what do you find in the container? Container is like an operating system. So what we have in the container, what are the things we have in the image? Okay, and what we have the image, whatever we put in the building. Typically, what is there in the image? We have the Python and the Flask framework and plus the code. It means as soon as the image run or the container run, your application starts, or application is being executed. Or it is also known as application will be deployed. So in this step of 5th, okay, final, it will be your final deployment part. Your application will be deployed in this computer, in the production computers. Or because application has been executed or be deployed in the production computer, it means any client who is hitting to this public IP address, they can see your app. What they can see, what is there in the container, but what is there in the container that is coming from the code of the app that has been developed by your developers. Okay, so till the step number 5, your deployment will be done to the production environment. Okay, so my point, guys, here, what I'm trying to tell you here is, It means as soon as developer change something in the code, something in the code, after the push, okay, automatically your CI part or the CI pipeline code will download the latest code, build a new image and push the image. Okay, that is mostly the part of build part, was called CI part. Okay, and then we can write one more pipeline here, and this pipeline is also typically known as CD pipeline. This for continuous deployment. CI means continuous integration, means integrate with GitHub or repository, do some build, store somewhere, do some testing, and some more thing we can do. Okay, CI part. But after this CI part is done, then we move to CD part. I mean, whatever you finally build, whatever software you created, this may be your Docker image, this will be a Java jar file, Java war file, maybe some other language code or the software, whatever you finally build, whatever package or also known as artifact created, what you want to do with your artifact or your packages. Obviously, you have to run it, right? You have to deploy it. And because there's a Docker image where we deploy the Docker, normally we deploy the Docker on some operating system, maybe Linux operating system. Now it is not always you have to deploy only in the production system. It will be any other computers also. Before the production, you can store another computer for testing, let's say staging area or testing team or testing computers. Okay. So after your package has been created, in this case, image has been created, you would like to deploy it. And for this, you have to first download this image or the artifact or the software. Then you have to run it. So if it's Java file, you can run the Java command. If you this may be the Ruby code and with the Ruby framework, all right, or like Ruby on Rails, for example. Or if this is a Docker image, you can run with Docker environment that we launch in this Linux operating system. Okay, and because we're going to launch the container, inside the container normally we have the app, and app has been launched, and that is called deployment. But it will be done automatically, and that is called continuous deployment. Why automatically? Because we are also going to write a pipeline for this. So typically we're going to write a pipeline, or I can say we're going to write a one single pipeline, one big pipeline that contain multiple jobs. One job we are going to write for CI, and one job we are going to write for CD. So when the pipeline run, two jobs will run, or maybe we have much more simple, smaller jobs, but main two jobs is going to run. One job will do the entire CI part, one job will going to do entire CD part. Okay, it means everything has been automatic. As soon as the developer write a new code, do a code changes, do a bug fixes, do bug some vulnerability, they patch, whatever they do, automatically they will be deployed to the production computers or to the final computers where you want to deploy. It will be production, or maybe a testing, it will be test, it may be staging area. It will be your call where you want to deploy. Okay, but in my case, for this setup to be run, let's call entire CI/CD part. For this setup to be run, okay, CI means integration part, especially build that you do is normally come under the CI. Okay, or I can say most CI is also known as build, most of the cases, not always, but most of the cases. Okay, so the build part come under CI, and after software build, your software want to run somewhere, especially in the production world here, is called CD part, continuous deployment or continuous delivery. You can use any other word, either deployment or the delivery. The small minor changes, difference I will show you in some time, but continuous delivery or the continuous deployment is the same thing, almost same thing. Okay, so for doing this setup, I need two computers. Okay, I need this computer where I'm going to deploy my final image and launch a container. So I need one operating system for this. And for building, I want one more operating system over this. So need two operating system. Okay. Now, if you want to run any pipeline, and if you need any extra operating system, then operating system would be known as runner. So I need two runner or two worker node over here. Pipeline code will be managed by GitLab. That's my GitLab manager or the master. Okay, but where you're going to run the pipeline, we need a runner. Now it is your choice. This runner would be your shared runner, or this runner would be your own specific runner. It will be your choice. In my case, I'm going to use my own specific runner. Okay, but in my case, you need two runners. So that's what I have launched, two runner today. So if we go to my settings, in my CI/CD, you will see I have two runner already been attached. Okay, for which runner we use for what purpose, and that is the reason every runner I have given a different tag names. So runner that has the tag name called ForceCI or my build. Let me use the term my build. So this runner that has a tag called my build, I will use for my CI part, means for building the Docker image. Okay, and the runner that's called final Linux, or let me use production here, any other tag you can use. So runner that has a tag called production, I will use for deployment purpose. Okay, you can use one node for both the purpose, for the same one node for both the jobs, but to make this practical a little bit more realistic, I'm using different runner or different computer for different purpose in one single pipeline. Okay, that's what the plan is. So I think my plan is guys clear. This was one of the plan and agenda for today. And on inside this, there's a lot of small topic gonna come up that will cover in this entire process. Okay. So to implement this setup, okay, and before we implement this setup, okay, one of the part is already ready. The part that is ready right now is we have the GitLab that is called master, and two runner already connected with us. So this part is ready. Okay. So before guys, we start creating a pipeline, let me do some small things in my pipeline. So if you see, I don't have any pipeline in this project. This is the new project we have created, no pipeline. So let me go to editor and create a new pipeline file that you guys know. This is the byte of a file we always create. So let me configure the pipeline. Okay, and by default, guys, they create this sample file here initially. So let me delete this file. I don't need this file. We have to get from the initial. Okay, so let me do a small test here. Test would be let me create one job. Let me give the job a name called build job. Build job, just can give any name. This will be a job name. And in this build job, I'm going to write a script. Okay, and a script maybe my simple echo and say I am build. This one job I created. Let me create one more job. It's called build, not build. I can say production job or release job, whatever job you want to write. Okay, typically these are known as stages: build stage, production stage. But in this pipeline world, this kind of block is not a job. So I'm just giving this term here. And again, let me write the script. Echo, I say I am production. Okay, this is what I'm going to print here. And now, because I told you guys, both the jobs run parallel. Sometimes parallel is good, but if you don't want to run parallel, then every job you can give a stage name. So let me give the name called stage build stage. And then we give this stage our name, let's say maybe deploy stage. Okay, and you're going to run your job sequential. So you can give the stages here that I want first stage to be run, that's called build stage, next stage to be run called deploy stage. That's what I show you in my last class. But by default, guys, I have 3 runners. 2 runner I connected from myself by myself. This is one, this is second. Okay. Or we have some third is a shared runner. So where this job is going to run, right? Let's see. So when I run this job, so where this job is going to run, then I submit, right? Your pipeline is correct. Your pipeline starts. There are 2 jobs here. First is 2 jobs in the pipeline. First is running your 2 jobs or here, and stage is different. This job is running. I don't know where this job is running right now. When I click here, you will see your job is succeed. This is very nice. I'm build printed, but your job is running inside the shared runner. Okay, shared runner. Then if you talk a second job, they will also, this is also been run. This is called deploy job. And this job is again running the share. Because by default, guys, your job will always run in the shared runner. Okay. But if you want to change, you guys know how to change this. I can go to editor. And here I can tell my job is one single pipeline. This entire code is pipeline code. But here I can say this job in the pipeline, I'm going to attach with the tags. And tag would be, according to my plan, my tag would be my build. My build. And because we can give multiple tags name. So whichever tag is free, you can, whichever the runner is free, they will run the job there, but let me give only one. And here I would run, attach this job or tag this job with the name called production. And I'm not giving this name randomly. This is what we have given to my runners, while creating the runners. This is what the names we have given somewhere here. If you see here, this is what the name we have given. Okay. Now, one single pipeline, but they are going to run this pipeline. One job running in different computer, second job running in altogether in different computer. It doesn't matter this computer running in AWS cloud, a local computer, Azure cloud. It doesn't matter. Now, what you will see, if we have running 2 jobs, but this job has been allocated to a different runner. This is the case in my case. Okay, and this runner is different, and they run the job in that particular computer. Okay, and this is one thing. And similarly, if you see in the second one also, you will see the same thing also there. And one more way to very quickly prove, even though you guys know it's been proved, but I say very quickly, I can do one small thing. After echo, I can also type host name command. Is one command that in Linux they will print the host name of the computer. Host name means, so in this computer, this is the host name. This host name is different. 182 other system host name is different, right? So let me again run quickly test. So now we have this pipeline created. Now we'll do a lot of things and changes in this pipeline. Okay. Now before I guys implement our final agenda, final means this one of the practical what I explained to you. I want to show you some basic thing that we need a lot. Okay, the basic thing is let me first show you this part to quickly test. I don't want any hurdle gonna come up. So if you see guys, right now they launched in IP 190. This is one of my computers. So it means technically my build computer wherever I'm running is having the IP address 190. Let me write here. We might need somewhere 190. Okay, and if you see the other job, there's a deployment job. They are running on the computer that has the private IP is 182 in the production. Okay, 182. See here, same computer. 182. So 182 is the IP address of this computer. Okay, we can also very quickly verify because there's a private IP, public IP is different. So this computer is the CI part IP 190. Okay, and this computer is a CD, means for deployment for production. This is a 182. This is what they printed here. Okay, so I think this is good. Now, before guys, I proceed and set up the Docker part. All right, I want to show you some small thing. GitHub guys give you lots of internal variables. What I mean by this, so we search for GitLab, okay, and this called predefined variables or the variable list. Okay, so GitLab has lots of predefined variables, and that's what you're going to use a lot in some time. Okay, GitLab has a lot of predefined variables. So these are the variables of the GitLab. So it means, sorry, whenever you create any projects, okay, lots of information about the projects, means what is your project name, in the project when you run the pipeline. Okay, so every pipeline guys, they have given a unique ID to the pipelines here. This ID 102, 162, 11013. Every pipeline has their own IDs. Okay, every pipeline is run from a repository. Repository is the last build number. Okay, all this information about your projects is being stored in special variables, and those variables are known as predefined variables. So there are lots of variables we have who commit your CI. Okay, the email address we printed, or a branch name, which branch you are running right now. Okay, or lots more information, your revision build number of the project. Okay, so when you run the project, what is that project number is stored in this variable. Okay, and a lot more details you have. So these are predefined variables. Okay, and so when you run the job, there has job as ID. If you're using the Docker images, Docker image also have ID. You know, by default they use Docker image. If you run in the shared runner, they run inside the Docker image. So what is the image name? As some more things, a lot more things. Okay, what is status of your job, the fail, the cancel. Okay, so they store in this variable. Okay, the job URL and much more thing, right? So a point here is this variable we're going to use these variables a lot, depend upon the requirement to requirement. Okay, but I just want to show you this variable is there. So almost anything and everything about your current project. Okay, all the major information that has been dynamically changing. One of the things is the dynamically changing the pipeline IDs. So when this pipeline run, next time when you run again, then when you run the pipeline, they will give a different ID to the pipeline. See here, there's a different ID going to come for the pipeline. So pipeline, this time pipeline running with this ID. So we see in the pipeline right now, this ID is different, but this ID is stored in a in a different variable. Okay, and this pipeline run with some kind of repository. In the repository, whatever the last repository commit, they store in this commit IDs. Okay, the commit ID of otherwise like this, there are a lot of things there. So they have a lot of variables. They store this information. This is one of the variable we have. Okay, now how can we use these variables inside the code? So you can use this variable very simply the way you use the variables, like an environmental variable. So in the pipeline, if you go to editor, and if you're interested in printing the IDs, so you can use echo command, give your environmental variable name, and you can use this symbol. That's all. So way you print your normal, for example, if I open my git bash terminal like a Linux prompt, and if I create one variable x equal to 5, and we don't give the space here actually. And if you, the way you print normal variable in the command line, with dollar symbol. Same way you can print these also. Okay, so let me save this code. One more new pipeline auto started, auto trigger. This pipeline has a new ID 849 in the last. Now we see, okay, what are the ID they have the pipeline? They will print over here. So here they will print this ID. Okay, so this may be not the ID. Maybe this is a different thing. Okay, hash of the ID, but whatever they have, they will print in this variable. I'm just trying to tell you that if you want to print any variable, you can print it. Any predefined variable, you can print it this way. Now, it doesn't matter if they contain the hash of it or they contain the ID of it, right? You can find some other things also to be printed. My point here, whatever the information you want to retrieve from here, you can use this data. This predefined variable, also known as environmental variable, to retrieve. Maybe this is the ID, might contain job ID. Let's just go and read the description, what they contain, right? So let me print this part, this for quick test. Okay. Now, why this ID is useful, I'll show you some lot of use cases in some time. Let me print here, just for example, echo, this one. So data of this environmental variable, it may be your job ID, or maybe your pipeline, because job also have the unique ID, they will print here. Let me run this job again. Okay, so now in this pipeline, we have 2 jobs running. Every job will have their own job IDs. Yeah, these are the different, every project has multiple jobs, every job has their own ID, and their respective ID we store in this variable. So if you go and open this, okay, guys, here 7175 ID they printed. So what are the job ID at this point in time? Because the job IDs keep on saying here 7175, exactly same job ID is being accessed by our code pipeline. And this ID somewhere can be very much useful. Okay, even though guys, some more internal information you guys can retrieve. Okay, even though whatever variable name you create, you can also use those variables name. So there's some use case gonna come up. I'll show you in some time for this, right? One more thing I would like to show you here is there's some special variables. It might be listed in this document over here that also contain, let me show you some special variable. If you try to search in the document, there's some variable name that also contain your username, also some of the internet tokens. Okay, for example, there's one variable name. Let me see here. A search for user. I think they should have user. Yeah, here. Here it is. Okay, so I told you guys GitLab is being also used for content registry. Okay, let me open the new tab. So we can use GitLab per project of the GitLab work like a own personal private registry. Okay, and this registry, guys, if you want to upload any images, you need to log in, and for login you need username and password. Okay, and the username is mostly the username of your account, this one, and password is the password. I'll show you what password you can use. Okay, so they show you here, if you want to use this, you need to log in, and here you to give a username, password, username and the password. So this username is this one you can use, but same username you can also retrieve by this variable. So let me use this variable over here. 1 minute. Okay, my code to check. So let's say I want to 1 minute. And why is important? I'll show you in some minute. This information will help a lot. So I'm going to print my username. Let me print some more information. I'm going to print my my registry details, the address of my registry. Like for example, in Docker Hub, this address would be hub.docker.com. In this case, your address will be different. This address may be this one, or this may be this one. Okay, so every registry has their own URL. So they print the URL address. So this will be stored in this particular variable. Or let me try to see some more thing. Maybe this may be one of the URL we can find. URL of your repository, actually, not the registry. The registry is different thing. Repository means where you store your code, like SCM2, like GitHub. Registry means Docker images, like Docker Hub. Okay, or maybe you might have one more variable that might contain password. It might have, yeah, this is the one. Then registry password. Okay, so when you want to upload something in the GitLab container registry, okay, you need to give the password. Okay, this variable who will store your password. Okay, so let me also check what password they store. Echo $ password. Because you guys, if you know about Docker push command, for if you want to push any images, you have to give the URL of your Docker registry, username, and the password. That's what I'm trying to see. Does they have the detail or not, or we have to add something else? Okay, so I'm going to print this. Just what I'm testing this, what they have. Okay, so in my case, they are going to run the job. And guys, here, if you see, they have given me the username. Okay, so they're not using this, my main username. They have some sub users with limited power. And name of the user is GitLab CI token. Okay, so when you're going to upload anything in your registry, internally they are using this username. You can change also if you want. Internally they are uploading into this URL, registry.gitlab.com. Okay, you guys said the same thing, registry.gitlab.com. So like in Docker is hub.docker.com or registry.docker.com, but here this registry.gitlab.com. So this is the URL this guys know. And password is been masked because of security, but then they also contain some password for something. Okay, so this is one thing. So upon guys, these are the lot of predefined variables. It's being used a lot while creating the code, and they give you lots of information while writing our pipeline as a code. Okay, this is one thing. So we're going to use this variable somewhere to do something. Okay, I will use somewhere whenever we need this. Okay, these variables, right? So before guys, I proceed with the remaining next part and trying to show you how the content registry work, how to upload and download the images from here. Let's first build it. Okay, and for building means what I'm going to do here, I'm going to use this part first. Let my developer first create a code in a Python Flask. Let this code to be pushed, and then I want it to be built by the Docker. And if you want to build, so in the computer number 190, okay, I need to install Docker software. Because if you want to build the images, you need Docker runtime. Docker runtime is the one who's going to build it. So what I'm going to do on IP 190 in this computer, IP 190, this is my CI computer, build computer, I would have to install the Docker. Why? Because if you don't have the Docker, it won't build the image. So minimum requirement for this computer or the runner computer is you need to install the Docker. Okay, Docker is a Yum software you can install with the Yum command. Okay. Okay. And after we install Docker, I will start the Docker service. That's all. That's what the requirement would be. And then I will start the Docker services. Now that's all. You can run the Docker images. I don't have any images right now with me. And without image, there's no Docker content launch, but Docker is running absolutely fine in my computer. Now what I want to do, this is my one IP 190 here, and this IP is my belong to my CI, or I can say build computer, and I want my image to be built. Okay, for image building, okay, what you need first your code, what code you want to build on. Okay, so let's say I'm going to create a code in Python or Node, depend whichever the language you want to use, that will be your choice. So I'm going to write a code in Python. Okay, so what I'm going to do right now, I'm going to write a code directly here. Okay, rather than the first write in my local computer, then upload here. I'm going to write a code directly here in my GitLab repository, and I'm going to write a new code in the same main branch, new file. Okay, new code, and here I'm going to write a code in a Python language. So let me give a code name app.py. It's a Python code. And those who know Flask as a language, okay, you can use, I'm just very quickly writing from Flask, import Flask as a function. Okay, I'm going to import some operating system, OS module. Then I'm going to start my app with a Flask function and give some name, my enter name to this Flask app. Then I'm going to run my app. That's all. Okay, run my app on what the IP would be. So any IP wherever they're running, I will pick that IP and run on port number, let's say 8080. That's what your application starts. So your web server application will start on port number 8080 where they're running. They're running directly on the operating system or running inside the Docker, doesn't matter. Okay, but what I want, if anybody come on this app, on the path, this called route. So anybody come on this app on the route called a path called /, then I want some function to be run. I say function maybe Linux world function. I want this function to be run, and this function is going to return and say welcome to Linux world. That's all. So very simple code. If you don't know Python, Flask, doesn't matter. Just copy this code and test this example. Right, so this is one quick code I created here. Okay, just for testing, maybe I might have some spelling mistake. Just for testing, what I'm going to do, I'm going to open my Windows. Okay, my Windows, guys, I already have the Python installed. I'll go to some of my document folder. Let me copy this code here just for quick test. I don't want any error because the code gonna come up. Okay, so this is my local computer. In my local computer, I already have the Python installed. Okay, save, close, and then let me run this code with the Python app.py. Okay, now guys, code run very much fantastically. There is no issue in my Flask app. Even though they give me this URL, and I hit this URL, they automatically pick my IP address of my current computer because I write 0.00, and my IP start on port number 8080 because I write 8080 here. And they say if anybody come on /, okay, automatically this function run and they will give me welcome to Linux world. So if I open this URL in my local computer right now, I can say welcome to Linux will come up fantastically, working fine. So this code is absolutely fine. And let me do Control-C. So if you want to run this app in your local computer for testing, you need Python to be installed, and you need also Flask software to be installed. After install Python, you can use pip command to install the Flask. Flask is one library. In my case, both is there already, so there's no error come up. But if you want to test in your local computer, install Python, and after install Python, the Anaconda, whatever way you can try, then install this Flask, then run this code. But my plan is to just to test this code. My code is working fine, say, so we can use this code. So this code has been created by developer. Okay, and this code has been uploaded by push command of Git, or I can actually copy here, whatever the way you want to create. So this code has been there. So let me save this code. This is my Python Flask app code. Save. Okay. But guys, to run this code, okay, that is there in your repository. Repository, guys, is only used for SCM purpose. So source code management system is there. But to run this code, you need an environment. Okay, before the environment, you have to build something. You have to build the package. Okay, so what I'm going to build, this is what I'm going to build. I'm going to build an image where I have my base operating system Linux, the Python interpreter, Flask library, and copy the code. This entire environment I want to build, and this is called container image. Why you need container image? Because my plan is to launch my app inside the Docker container, and that is the reason I need to build container image. And guys, if whenever you want to build a container image, you have to create a Docker file. So I did Docker file. So I believe, guys, if you go through my Docker videos, they are explaining very detailed about the Docker file. Okay, so I'm going to create a Docker file directly here. Again, in my repository, I'm going to create one more new file. And this file is called Docker file. So whenever, guys, you want to create your own custom image, okay, custom image, then you have to create the Docker file. In Docker file, you have to tell your base image name. You can use any base image name, maybe CentOS and Ubuntu, something like this, or you can use Docker Hub and search, do you have an image that is Python pre-setup? Okay, so you can find a lot of Python pre-setup images available. Okay, with multiple different versions, whichever version you would like to use. Okay, or maybe you can check, do you have any image with pre-installed Flask? You can also find it. But let me use this image, Python latest one. So I'm going to use a Docker file for my base image with Python. Whichever the version you want to use, you can use, but let me go for the latest in my case. By default, they use latest only. Okay, now in this Python image, okay, what I want to create inside this image, I want to create a new folder that's called a working directory /app. You can create anything, doesn't matter. Okay, but why I want to create a separate folder? Because inside this folder, I want to copy, this called add, all the data in this folder. Which all data? All the data. Dot. Older means is my current folder. Right now, my Docker file is there in this repository. Here in this repository, but let me open the new tab. In this repository, I'm going to create a Docker file. So all the file in this folder, app.py, all the other files, especially app.py. So I want to copy my app.py app.py inside this folder. Or maybe you have much more file of your app. Okay, so better you can use dot. So all the file inside your current repository, 1, 2, or hundreds of files and folder will be copied inside this folder. Okay, so I'm going to build a new image, my base image Python. In this image, I'm going to create a new folder. In this folder, I'm going to copy all of my code created by developer, and this code is there in my current folder. So I write dot to copy everything. Okay, and because this code is based on on Flask. So I can use pip install command to install the Flask here. Flask here, maybe F is capital small, I don't know. Everything small is capital. Both will work. So let me use anything. So Flask, let me use capital. Okay, guess insensitive it is. Okay, and if you want to run any command inside this image while creating the new Docker image, you use a run keyword over here. And finally, after this image created, when anybody run this image, automatically I want some command to be run. And the command that I want to run is this one. This command. This command I want to run, because this is a command who's going to run my app. Okay. And here in the command, guys, normally we give the command in the list format, and every command is like a one element. So guys, again, this is not a Docker class and this is not a Docker file class. In my Docker classes, this topic I explain you from very basic to all the advanced if you go through my that video. But this is what we have. I just very quickly explain you what I'm doing here. Okay. So one of my DevOps engineer or maybe my developer, okay, create this image, create this file. It's called Docker file. Why? So app is my web app, is my final web app. But where this web app is going to, how to set up the environment for the web app, and this instruction I put in my Docker file. Here I say my web app need to copy here. It is going to use Python interpreter with base operating system, maybe inside they're using Linux. They need a Flask. And when I want to run the web app, I need to run this code. Like here, you don't need to give this path because I make my /web app is my root path. So anything inside the /app, you don't have to give the path. You can directly type the file because my working directory, or known as a root directory, is now /app, is not now /. It's not /, it's now /app. So you don't have to give the path here. Okay. So this Docker file has been created. Okay. So let me save this one more file here. Now, technically inside your repository, you have two files. One file is your app, that is your final web app created in Python or Node, whichever language you want to use. But for this app, whatever environment you need, okay, you need this four thing: either SOS, Python, or Node, Flask, or Express in the Node, or your code in JavaScript or in Python. You have put everything together and become a new environment. I hope who pick all the thing together as a bundle, this Docker file. A Docker file is just instruction you to create this environment, or you to create this image actually. And to create creating the image, you need Docker file. That's what we have created here. Okay. So now this setup has been done. Now finally, you have to create a pipeline. Okay. And what pipeline will do? We'll do CI part. CI part means, let me show you while writing the code. So my CI/CD, I'll go to my pipeline editor. Okay. And I say, whenever you're going to build the job, maybe you print all the things that okay, doesn't matter. But I want to do one more thing. Okay. I want to do one more thing. What I want to do, I want my Docker is going to build a new image. An image name, let's say my Python app. This was my image name. Okay. And for building the image, what you guys know need for building the image, right? You need Docker file. So let me refresh. You need Docker file. Okay. And Docker file, guys, is there in the root directory of your repository. Okay. So you can write dot here. Because when you run the job, by default, internally, even though, guys, let me comment this line. Let me remove this line even. Maybe comment this line. So if I run this job, guys, one more time, this line I just commented. What I want to tell you here is, whenever you run the pipeline, automatically, guys, pipeline by default nature is they will always download your current repository. Okay, see here, they automatically download your current repository. Okay, you need or you don't need, when you run the pipeline or the job, okay, your current Git repository, not GitHub, Git repository means this repository, this one, okay, they download. See here, this exact same Git runner, this repository from my account named third project, this third project, they download. It means whatever data you have in the repository is a part of this job. Okay, and how can we check this? It is obviously visible, but to quickly check, in my code of this file, or maybe in the CI/CD editor, okay, you can very quickly check by printing the file cat app.py. So in my current repository, I already have this file called app.py. I'm just printing the data of it just with the cat command, just to prove that it is there. Or maybe I'm going to print the Docker file also. So in the current location, this file is there, and this is what they're going to print, the data of this file. So here, guys, they print the data of this file. It's my Python code. They print the data of the Docker file. So I'm just trying to prove you that while running a job, all the data of the repository is by default downloaded. So this part that you run the job, you need to download the data, is by default handled by the job in the pipeline. You don't need to do it. Okay. Yeah. If you guys using Jenkins, then you have to write some extra thing in the job. But here, this is by default nature, right? Okay. Now, only thing what we have to do, my editor, is I don't want to use this. Instead, I want to do this. Okay. I want .miss in my current location where the job is running. Okay. You can find Docker file, because Docker by default looking for Docker file only, where D is capital. Okay. And they run the Docker file and the build a new image with this name. Okay. But where this Docker build will run, or where the job will run, the job is running inside this runner. So they build this image inside this runner, and where this runner is, in my case, this runner is this one. This one, IP 190 here. My build system has IP 190. Okay. And right now, if you see, guys, I don't have any images here. Now, without having any code in this computer, I don't have a Docker file in this computer, right? Neither the code in this computer. Okay. Everything is being managed, centralized in my GitLab. My code is there, app is there, Docker file is there. Okay. But this instruction from the Docker, from the GitLab coming to this runner and ask this runner to build the image. Okay. So let me show you. So now when I run this, just this one command, and now if you commit, you will see now this job is being started. And in this job, what you will see, this job is failed due to some reason, but something they're trying to do. Okay, this job first of all running IP 190 is my runner node for the build computer. They download the Git repository and they print some message what I asked them to print. Then they run this command, they fail. Okay, why they fail? Because behind the scene, your all the command in your runner don't run from the root power. Right now, this I log in with a root account. But internally, they are not running with the root power. Okay. And if you run any command in Docker without the root power, it will fail. What I mean by this, if I run my job one more time very quickly, if I run my job one more time here and try to print who am I, means from which power you run this command, they will tell you the username through which this job has been run. So very quickly again solve the same thing over here. And now what you will see, okay, they run this command with the power of some other user, and the name of the user, what they use is GitLab runner. And if you remember, this is the same user what I created while creating the runner. So when I creating the runner, and while creating the runner, okay, there guys, I run one command in my runner. So if you see the instructions again, open Linux, there I created this account. Okay, so that any job from the GitLab want to run in your slave computer code runner, they will run with this account power. This is what we have given here. So all the job from the master is going to run the GitLab runner is going to run with the power of this user. And this user have a limited power. This is not the root account. Okay, and that was there because they have a limited power. This is in why this job whatever I run this last job failed. So what to do? Okay, so multiple way we can solve this. One of the way we can solve is, because this is about the Docker only. So in the Docker guys, there's one way they solve this problem. Okay, so what they say, wherever your computer is, okay, if your user name called GitLab or runner available, okay, and if you want to give this user a power to run the Docker command, so what can you do? You can modify this user, this called user mode, and put this user in a group called Docker group. Okay, so this is one of the way to solve this issue. Otherwise, those who know sudo, you can use sudo also, and much more way we can do. Okay, now this user now is a member of Docker group. Last time it was not there, but now is a member of Docker group, and any user who are the member of Docker group, they can have power to run the Docker commands. Okay, have the Docker command. That's what we have to do. This is one of the way to solve it. This is just a permissions point of view in the next. So let me run my job one more time. Job means pipeline. This pipeline is failed. So when I run this pipeline, let's see they work or fail, or maybe to do some more thing here. My intention is guys here is now it look like it's working. So now this command started working. And this command is building the new image. So for building, they selected this 190 according to my diagram. They selected this system 190 for building the image. And this is my sample runner running somewhere in my local computer or maybe in AWS cloud. Okay, so build is going on. Okay, it takes some time because internally they are downloading this image. So in my this system 190, I don't had any images, but now if you see, they are going to download one Python image here, because the minimum requirement is I need Python image. So they download it. After they download this image, they done change the working directory, they copy the entire code, they install the Flask inside this image, and then there was some other warning that can be we can change in the Flask. This is the warning, right? Because doing something in the root power inside the Docker, there's a different point, but finally the image has been built successfully, job succeeded. Okay, where the job is running inside this OS. So we go inside this OS 190, what you see, you can see one new image created. 57 seconds ago, we have created this. Okay, and what this image contain? This image contain all those four things: Linux OS, Python, Flask, and R code is there inside this image. So this part, number one has been done. Number two step has been done. Okay, this part, downloading the app is automated. Always they do for us when you run the job or the pipeline. And number two, we have done by ourselves by getting the code from my developer of my app, or by writing a Docker file maybe by ourselves, or by some of the DevOps engineer or container engineer can do for us. Okay, that's all. And we as a CI/CD engineers, right, we have to write pipeline, something like this, where the important line is only this one. Otherwise, everything is just writing as a dummy, but this is the main line. And where you attach, this is again the main part. So which a computer attached, your system should have the Docker runtime running. Okay, so this part has been done. Now, the next step would be, after this image being created, okay, you can run the image there only. So maybe you can use one computer for building the image, same computer to running the images for deployment. You can do also. So let me do this part very quickly. Okay, so maybe for deployment, I'm going to use same computer. That's my build. Let me copy this, and I'm going to do all the thing in the same computer. Okay, I'll show you the different computers I'm mad. Okay, so same computer I'm going to use for building, same computer I'm going to use for deployment. How to deploy? So those who know Docker command, to run any container, we use Docker run command. And then we give our app name, or my image name is called my app. This one. This is my image name I have to give. Okay, so this is my image name. And every container, guys, we give a different name. Let's say this is my container number 1, or maybe app number 1. Okay, that's all. And normally we run the container in the background with option called -d to put in the background. Or maybe we can do IT also if you want to go after some time inside the container to see something there. I can write IT. So this is very typical Docker command. You guys might know this command. Okay, but this container, guys, is running in your my build computer, means in this computer here. Right now, there's no container running. There's no OS running. So this will run the container. But guys, you know about Docker container, they run locally. Okay, nobody can get from outside world. But if you want anybody can get from outside world, you have to do patting, or the network port translation, and say anybody come on this main computer on the public IP of this computer on port number 80. We send this traffic to port number 8080. Why 8080? Because if I again open my code, okay, of my app. So in my app, it is written my app is going to run on port number 8080. Okay, so inside the container, my port is running on 8080, or my app is running on 8080. So I'm going to write here, anybody come on my system where Docker is running, this computer has the public IP also. So anybody coming on the public IP of this computer or this computer IP address from outside world on port number 80, the traffic has been sent to port number 8080 inside this container. Inside the container, my IP is running, and that is running on actually 8080 port number only. So again, this is a very basic Docker command. So those who know Docker, this is one of the basic command we have seen in my Docker classes. Okay, so I build the Docker image in the same computer, and same computer I'm going to deploy the Docker. And now if I save this, you will see in some time you will see one more Docker container. See, very quickly they run it. because this job run very quickly. But yeah, actually, they launch here. This is for building purpose. Actually, this is not the main one because they are building the image. So building also run inside this one. But point here is now job run, build part is done successfully. There's no error in the build. One more new image created. Okay, or I can say the older image will overwrite because I give the same name. Override. But if you see second job is been also completed successfully. My deployment job in the production completed successfully. Okay, and commit successfully, and they run completed successfully, and they run the container. Okay, and if where they run the container in this computer 190. Okay, in this computer 190. And if you see the Docker PS command, you can see one from this image. I launch this container. Okay, and now anybody come on this computer, okay, on port number 80, they can go inside this container and connect to the port number 8080. This is where the app is running. So this port you can't give randomly. Whatever the app port is, you can write this. This port can be anything. There is a kind of port you can do change by yourself, but what a port you write, your customer will connect on this port number. This is a very basic thing about the Docker perspective again. So now anybody who know the public IP of this computer, this is a public IP of this computer. Okay, anybody know this IP address and use port number 80, and they come on HTTP protocol, they can see my message here. Fantastically working, right? So technically for the client perspective, they can see my website. They can see my website, but this website is running inside the Linux OS, inside the Docker container. The entire CI/CD part, building the images, or maybe some image code required compiling, some library having on separate images or environment and find deployment. Everything is done automatically. For example, this image doesn't look, this output of this website doesn't look good. So now what you have to do, your pipeline has been created. You don't have to worry much. Now your developer will keep on changing the code. You go inside the app, and inside the app, they edit something. Edit maybe, let's say I want to give let's say header. I add the header code. Okay, so my developer now focus on the code, and as soon as the tap the code and change the code, okay, automatic guys, your build starts here, pipeline starts. Okay, and everything is automated. Now developer has to just focus on building the code, and now, and as again, you can see the latest updated website gonna come up. Okay, obviously we had to write some testing also in between. There's a different point. Okay, but it's fail. I don't know why they fail. Pipeline fail. Let me check. Okay, they fail. I know one of the reasons why they fail, but let me show you from the output, because we have given the same container name. And if you try to create app container the same app name, it failed because this app name is already there. So where my system is, so this app name, where my system is, 1 minute. So this container name already exists, and if you try to create any images, or so any container the same name will fail. All the container names should be different. Okay, so how can you give every time a different container name? Two way, either every time I can delete this app and then launch a new app. This is one of the simple things we can do. Otherwise, we have some more way. I'll show you in a minute. So what I can do here in my in my pipeline. Okay, whenever I want to create a new app, before create a new app, I can say Docker do one thing, remove forcefully this app. the service call will contain, remove this app container forcefully. Okay, then create a new one. This makes sense, right? So that was the reason, guys, they failed. Now this pipeline again start, and you will see in some time we will have the latest website with the better content. The developer has to just focus on the code. My pipeline is started. It's been creating. I design some time. It's been creating here. That is done. Right now, if I refresh, you can see the updated code. So pipeline you have to create once, maybe initially because you are learning. We can do multiple tests. A lot of time you have to keep on checking the code. For example, right now if I change something in my code, thing will work automatically. When I change something in my code, let's say I want to give my my edit in my code of my applications written in Python or whatever they would be. Let's say I want to give my body tag, BG color would be let's say aqua color. Then I want to close body part. Okay, here. So some more code I added here as some HTML code for web applications. If I save this page, automatically my job run. Okay, so save this code, my job run, or we can run our job ourselves. Okay, and now if you see in your CI/CD pipeline, okay, so your job is not run manually, but we can run it by ourselves. Right, it's not run automatically. Yeah, actually they run very quickly. Then I thought they don't run due to some reason, but yeah, there's no updated sites gonna come up, right? So it's work, right? But right now, because we are learning, depend upon situation, you might see some of the time pipeline fail. It takes some time to mature a pipeline. Right? For example, there's a possibility, according to this code, if you're running your pipeline first time. Okay, so because I changed something in my code, and initially I have no app running. So let me remove the app manually. I manually remove this app. There's no app. And let's say this is the first time you're running our pipeline. Initially, we have no container and no app running. Obviously, there's no app running, so nobody able to connect. That's for sure. It is not working. Okay, because there's no container and there's no container, there's no app. But now in this case, if you try to run the pipeline one more time, there is my possibility your pipeline will fail. We run the first time. Why? I'll tell you if they fail, then I'll tell you why they fail. Okay, so your pipeline is running. So last time I tested my code multiple times. It was working fine. Working fine. It might fail. Depending. Fail. This pass is nice, but it might fail. But the pass is nice. Why I was thinking it's fail, because guys, when you run this command, okay, this command don't figure out this app. In this case, actually this line fail. If this line fail, they will fail the next line. Maybe in this version of Docker, if they don't find any app, they might not giving the error behind the scene. They move to next line. There might be reason. Otherwise, now you can see new upside come up, right? Otherwise, when you run the first time, because image or container is not there, so this command don't able to see it. They say no container, so they might Intel throw error, exit code, something like error code. And when any command throw the error code, they will won't go to the next line of your job. I showed you in my last class already this point. In this case, by chance, this command is not throwing error code. This what we are lucky, but in such situation they might fail. So in this case, what you have to do, you can do write some kind of shell scripts, right? So then some kind of tweak we can do. For example, you can do something like this. If this has happened in some scenarios, okay. So if I go to my editor and say in the pipeline and say, this is what we want always. I want my image to, my content to be always delete. But in the case, if the content is not there, most probably the first example or my first time when you run, then I say I want to do OR condition and set true. True is a keyword in the command line. It's a cell keyword or a command line keyword. Okay, this is OR. If this line successful, this is true, this is true, both the true is if I write the OR between two is become true. But due to some case, this line fail, this is false, or this line is true, is true, and if you do OR between false and true, it's again true. Means I want in both the cases this line will or this statement will give the true or success. Okay, because this line in some situation this will fail. I don't want, because this fail, they will go fail the next one. Technically, I want if the app is or content is there, I want to remove it. If the content not there, they will fail. I don't want they will fail. So I will write or true. So I think you understand what I'm trying to tell you. So here is in this version of Docker is not working this way, but in some version of Docker, this command mostly give the error or the false. That makes the next thing or next part of the steps of the job makes also fail, and entire job will fail. In this case, it's not happening, but this is good to know. Sometimes very useful to have this concept. So this is now running, and now you can see new website. What are the website change you done? So my point here is, as we keep on using the pipeline based on the different scenarios, we keep on building the new code here depending on the requirement. But now guys, still here, this part is done. Okay, which part? This part is done. Okay, we have successfully built and launch or deploy the container. But now in this example, we have done only in one computer. So building and the deployment, both things has been done in one single computer, computer number 2 or computer number 190. But typically what happened, normally we build in a different computer and we deploy in the different computers. And the different computer may be your staging computer, testing computer, or maybe your production computer. Okay, so how to do this? Before we will do, I want to show you one more small thing. Now what happened guys right now, every time when we are writing and changing something in the pipeline, or maybe changing something in my code, okay, it will run the pipeline. That's what we need. But every time pipeline run, it is creating a new images. Obviously, that's what I want, because the code change, I want image to be created or new image to be created. But the older image will be overwrite. So if you see your computer, what you see, your older images will be overwrite. Okay, even though they're showing in London, but they keep on uploading, overwriting the older images, and you don't have any access of your older images. Only latest change image is available. Okay, sometimes it's good, but most of the cases this is not the good practice. Okay, this is a good practice, because right now this image containing my latest code of my app. Okay, and now due to any reason, okay, for example, in my code we have done some spelling mistakes here in my code. Spelling mistake, and due to the spelling mistake, okay, and when you save this changes, automatically your pipeline run. Okay, for the pipeline this is just a file, and for the Docker also this is just a file. Docker have no idea you have done the spelling mistake. So step now 1 run automatically, 2 run automatically. The third step means the automatically build done. There's no fail in Docker building, image will create. But when you run the image, Docker also run the container, but container is going to run the app, and because in the app we have the error, that time it will fail. So what I'm trying to tell you here is, if I try to show you in the pipeline, okay, this pipeline runs successfully, and when I try to show you over here. This build job runs successfully. There is no error because we have the error inside the code. The code is just a data for the container. They have no idea. There's a code, there's a document, there's an image, or there's a normal photograph or the video. They build this image successfully. Okay, but in this building, they override your older image. Okay, older image. Again, if I go here and they override the older image here, this image override. So last image, you see guys, this was a 4A number come up. This is 87. It's been updated. Last image I had was running with a code that was running very fine, right? There's no challenge. This was running fine. Okay, but now new image created, and inside the new image that's called built successfully, this new image override the last one. Now there's no way to get this image back. And why I want to get this image back? Because the new image has the new code, and new code has a bug. It's not working. How I know? If I try to refresh this page, you might see it is not working. It's here, failed. It's not failed because of Docker. It's not failed because of the pipeline. It's failed because my code has the bug, or my code has the code issues. Maybe spelling mistake and some other big challenge we have. But for the pipeline perspective and for the Docker perspective, they won't see any error because this is error inside the code. A point but here is what mistake we have done here. Okay, because this is a very common thing. All this image was containing the older code that was working fine. My developer or some other team member had changed something code that has a bug, and because of bug, they again run the pipeline and they override the older images with the new image. And this new image has bug, and because my site goes down. Okay, in this case, what can we do? Nothing. My developer had to go and find the bug, and after finding the bug, they will update run the pipeline again to find out and recreate the new image. But that will take a lot of time, maybe 1 minute, 10 minutes, 2 hours, depending upon how much the depth the bug to be take to resolve. Okay, so what can we do? By the meantime, if you have the older image, you can at least start that image. At least your customer can see the older website, because you know you are changing the code something in the website, but customer doesn't know that something is going to change the new in the website, right? So at least customer can see the older website, right? Older website. But older website can only come when you have the older image available. From this image, if image is not available, how can you show your older websites? So typically, guys, I'm talking about rollback concept. Okay, and the versioning concept. Okay, so what I'm trying to tell you guys here, whenever you build the image, always create multiple versions of the image. Version 1, version 2, version 3, and keep all the versions, keep all the copies. So that whenever letters come up, and if letters has the issue, we can roll back to the older one that was working fine and smoothly. Until the time, that's my developer trying to find out the issues, what issues we are facing over there. Okay, so that is good practice to have the versions. That's what I'm trying to explain you here. How to do this? So simple. Okay, we can do a version. How? I'll tell you. But right now, if we see the job and pipeline, okay, both the jobs run successfully, right? Even though when I click the latest one, both the job run successfully because they won't see a bug in the pipeline. So they launch the content also. The content also launch. Okay, because my content, the app is running. So that time they found out app is not there. So after they launch, they will terminate at a different point. But for the job perspective or pipeline perspective, everything is good. Even if I run my pipeline again one more time, my pipeline won't see any issues. They again run successfully. Okay. But after the container launch, after this container launch, this container launch, maybe here or maybe in the same computer, doesn't matter. Then they come to know, okay, that we have the bug. For example, if you keep on refreshing, you can see my container launch, and after the container launch, they have the bug. They have some issues in the code. So now this line is going on, this is going on right now, then they launch and they show the bug. So point here is simple say that I already explained to you. Always create a not override your older image. Okay, always take a lot of time, I don't know why. Always create this part is done successfully. Now next job is going to start. So they will launch it quickly daily. There's a different point because the app is not running properly. So my point here is always get a backup of it. So before they let me fix my code, edit. I had the issue over here in my code somewhere. I fix my code and save. And as soon as save, now automatically my pipeline will run. And this time my app will have a right code. So my contents start and my contents keep on running because my code won't fail. Because container, the way I create a container. So if you see the Docker file, the way I create a container, my container is purely depend upon my app. So when they run the container from this image, okay, if the app running, my container running. If the app fail, my container stops. So if you guys go to Docker file video of my video that I explained to you, the life of the container is the life of this command. If the command fail or command stop, program stop, your container stops. That's what the container stops. Okay, now here the container is running because there is no error. The container running because of this command. The command has no error, so container is keep on running. My client can see the website. Now, how to fix this issue? So next time, any issue come in the code, at least you have a backup copy of the image. This is called versions. So for this, one small thing we can do here in your pipeline, while creating the image, always give image a version. By default, they take the latest version if you type or don't type. But always give a unique version. Okay, and unique version should be unique always. I can't give V1 because at V1s every time they become V1 only. They can overwrite. So you don't give the static version here. Instead, you can give some unique versions that keep on changing. And that unique version you can take from these variables. Here the use of this variable gonna come up. Okay. Now every time, okay, whenever this job run, this pipeline run, inside this pipeline, this job run, every job has their own ID. What ID that the job has that point in time I'm giving over here. So let's say job has ID 1. So my image name would be my app :1. Then my app :2. My app :3. And every time we are giving a new ID, it means they're not going to override my older images. And we have all the versions of images available. And anytime we can do rollback. Okay, that's what we can do here. Okay, similarly, because your image name is different, you use the same image name also here. So your image name my app :1, my app :2, same my app :1, :2 we are using to launch that. Okay, but before I will launch, I will remove this. Okay. Understand one thing, guys. This is the image name. This is the container name. Okay, we are removing the container. Container name you can give anything. Why? Because we are removing every time. Okay, so this is better practice, I can say, to do it. Okay, again, guys, I'm considering that you know Dockers, right? And I'm just explaining you on the top of it in a way that you know Docker. So I'm just going in my flow as a prerequisite for this program that you know Docker. Okay, so commit changes. Now what you will see this time, Okay, this time in your node, you will have new versions of the image here. We get new versions. And this version is not static every time it changes because its number is coming from my job, or maybe you take the number from your hashes, or maybe get from pipeline ID, whichever number you feel it will change always. It's not going to conflict, right? Then you can use it. So new image created with this version, they're not overwriting with the older one. Okay, both the copy we have is called versioning of the image. So sometimes if this image has some issue, so we have an older copy, we can quickly roll back. We can keep it launch this, maybe manually, or maybe can have some automatic script for this in my pipeline to perform this, right? And now one more content launch. I'm going to launch. It's not launching. Maybe some part might fail. Let me check. Okay. So, so some part is failed. One part of the job run successful. This part run successful. That's what my image has been created. But this part is failed. Why they fail? Why they fail? Because okay, they fail because, guys, of this reason, right? Now, this was a small mistake I've done. One reason is very simple, because idea is one thing. I am creating the image from the different job and running the image from a different job, and obviously this job with a different ID. So here this ID may be 1, but in this case this job is different. Here my ID can be 2. Obviously the same image won't match there. So in this case, using the job ID here doesn't make good sense. In this example, we have to use some ID that is common to both the jobs, or maybe my pipeline ID. So yeah, I go to my document, the way I show you in my variable. So if I can search where it is GitLab predefined variable list and search, do you have any ID that is common to all the jobs? It may be anything. It may be hash, it may be branch name, it may be commit version of the project, or maybe let me search for job IDs. In a job ID, internal ID is not job ID. Job ID is different for every job. It may be my project ID and something like this. But you guys got the idea, right? This is one of the use of instance level ID current pipeline. So this may be one thing we can use. Okay, so we can use over here. So in both the cases, obviously pipeline will have one single ID at that point in time, but every time they change, every time they change, let me also print just for checking what they printing here. Okay, and in the one pipeline, because every time they change, that's what we want. Okay, every time they will change, so I will have different multiple copy of the image built. Plus, we might have multiple jobs, but pipeline ID is always same. So we can use this ID in both the places. Okay, so let me again commit. Now every time job run or pipeline has ID. For example, here in this case 630. So they might print 630 here if this throw in the same variable. So let me check very quickly. Same variable, both successful. That's nice, but they write the print the pipeline ID 630. So this is what the pipeline ID we store here. My pipeline ID, what the pipeline ID would be is the job ID. Pipeline ID is actually I'll show you what is 630. And now my image has been created. My image has been created. With the same ID of pipeline. And again, from the same image with the same ID, we share same image from the same ID 630. We launch the app. And now my app is accessible to the client. And one last quick test before we proceed next. one last quick test. So if I do some changes in my code, okay, maybe I'm going to put my name Vimal Daga here. Okay, I would like to normally prefer write in capital letter. This is called capitalized, but if I do some changes in my code, okay, and I save change, that's all. Now, if you see, your client can see the latest copy of the code. Plus, internally, you're also managing the multiple images also. So by chance in latest code, some part is failed, some part is failed. So you have an opportunity to roll back. Okay, because you have multiple versions of the images. So let's see here. Now new latest copy come up. My pipeline work very much fantastic. But at the same time, if I go to my runner, you can see new image they use for launching the same app. And here you can see one more copy they created 42 seconds ago. By chance this will fail, so I know how to work back. I can go and use this image either manually, or we can write some automated script in my pipeline to do the same. Okay, so do the same. So that's what, guys. So let's go for a small break. Before the break, any query if you have, then we'll do some more part. Now we will go to next step, how to push the image to the content registry, and from there how to put this image into person computer. So that's what we're going to see after the break. Before this, any query if you have, you guys can ask me. I believe no. So let's go, guys, for the quick break of 25 minutes, and after break we'll continue. Bye. See you. Okay, so guys, welcome back and let's continue. So next plan is what we have done till now. Very quick revision, right? So now we have a developer who write a code, upload into our SCM system. That is our repository that is managed by GitLab only. Now we have a one pipeline called CI pipeline. It is actually one kind of job. Okay, what this pipeline is doing, they are getting the code from SCM. This part automatically they are doing for us. Okay, and after they get the code, they are providing this code to one of my runner. That is one of my self-managed runner over here in my Linux operating system, and providing this code, okay, with two things. Actually, they're providing the entire repository, and repository contain two things. One is my app code in Python, one is my Docker file. Okay, and based on the Docker file, in my job I write, based on this Docker file, go and build the image. Okay, so runner is the one who going to build the Docker images for us. That was successfully done. Okay, now what I want, this step number 2 is done successfully, and we can see when when I run my job, we have these images created. Okay, fine. We are also maintaining some versions and all the things what we have discussed already. Now what I want after this image build, I want my CI job will do one more thing. This image I want they will store in the centralized registry, this whole container registry or the container center storage. Okay, that is your choice. You want to use the registry from the Docker Hub, or you want to use this registry from the GitLab from your own project. So right now we are into third project with our project. Every project has their own repository like SCM and their own CI/CD pipeline. Plus, in your same project, you have your own registries. Okay, and that is called container registry. It's like a more like a Docker Hub. But if you see in the container registry, in this project is new. So in this project, in this registry, we have no images available. Okay, so if you want to store the image, you have to log in with this registry first. And for logging, we have this command. You log in with the registry. But who is going to log in? If you want to upload the image by yourself manually, you can log in from the command prompt. But in my case, I want this image to be uploaded by my pipeline. So this step, I will ask my pipeline to be done. So I'll go to my pipeline code. Okay, I'll go to my pipeline code, and in this build job, I will write something here that I want first go and log in to this registry. Okay, which registry? This one, this registry. Give out this command. So let me copy this command and log in to this Docker registry. Okay, again guys, when you want to log in, okay, when you want to log in, typically for login, you have to give a login and password. Okay, you can't directly log in to the system. And for login name, right, I can use U option. This is a very common syntax of Docker. And for the username, you can take the username dynamically from this variable. So there's a username you can take from here. Okay, and for the password, you can take the password with P options from this particular variable. Okay, or you can also take the registry name also. You don't have to type this. You can take the registry name from this variable. That's also can be workable. Instead you give the name, or you can give the registry name by this variable. Okay, so this line will help you to log in to the Docker registry. That is our own personal Docker registry. Okay. So let me run this code to see at least this is a command line running fine, or we have some errors, right? So let me change automatically this run will run for you. And I want to check that when you run this job, this will running fine or not. Okay. So job succeed until they run this command, and this command is going to find out your URL, username, and the password, and they type all the things here from this environment variable, and they say login succeed. It means my project pipeline has a successfully logged into my this registry. Which one? This registry. After the login, we have to, when we see the steps also, we have to build the image. And for building the image, you can let me copy this command, and in my code, I'll type how to build. Even though in my last example, we already built the image with the build command, but normally we build the image after we log in. It's not always true, but we can do in this way. So I'm building this image with this name. Now, my point here is those who know Docker, okay, you can build the image with any name, but when you upload the image, okay, you upload the image by this fixed naming convention. So this, so you can build the image with any name, but if you want to upload the image, your image name should contain your your registry, means the URL, then your workspace, your namespace, because the registry.gitlab.com is a public cloud, and everybody, they have created a separate folders, right? So in my case, because my account name is Vimal Linux World 13, so this is the one workspace or namespace they given to me. Okay, and because I know my password, I can use my password to log in, to connect. So you can't type anything. So this is when this line is fixed. Okay, so when you build the image, you have to give the name. Your name would be anything, third project and something like this. Even though that third project is also very important. Yeah, even this you can give anything, but normally this is because right now in your account you have multiple projects, and right now you are building the image, and every project has their own passwords sometime. Okay, so internally they are using here this password. This is a temporary password they use, and this password is per project. So this password you can only use to connect to this GitLab, not to Docker Hub. In the GitLab, you can only connect to your account, your main root account, not other account of the GitLab. And this password can only be workable in your project, not in other projects in your same account. Okay. So when you build the image, okay, you can give any name, but you want to upload the image. If your naming convention is not this one, you won't able to upload. So that is the reason I'm going to build the image now onward with this naming convention. Okay, over here. After build, I can upload. How? This is the command, push command, you know, in Docker, we can upload by this. Push. So let me run this code. Okay, obviously this part will fail because some of the things have changed, but let me at least focus on this part. Okay, so this command is going to log into my local repository, or not repository, so normally known as container registry. Then the build the image, get a new image. This image is going to build into my runner only, but automatically either build the image with any other name, then you can change the image name with the tag command if you know, or while building only, you can give a proper naming convention, because if you don't give this proper convention, push command don't work. In push command, you have to give your URL and your account name, then your project name. This is mostly known as namespace in your Docker registry. Same namespace convention we use in Docker Hub also. Okay. So that is the reason when you build the image, use the same image name, and same image name can be helpful to give the entire URL of your Docker push command where to push. So this concept again I explained in my Docker classes about this naming convention. Okay. So let me run this code. Let's see what happened till now. So again, when we run the pipeline, the first job is running. And what you will see, we have login successfully. That's nice. First command run successfully. Now we're building the image. Okay, same way with the way I showed you in my last example. We're building the image. Building this image is going to build on my runner only. Same process. My image has been building. My image building is successful. Okay, successful. And this image is going to build in my runner only. So if you see in Docker images, this image build in my runner only. But only thing is name is different. Okay, is done here. Now, final thing, they are pushing to this URL, and we try to push. Okay, and they're pushing here, and finally it's been pushed successfully. Everything worked fine. Okay, everything worked fine, and very quickly they push. Because in my case, they work very quickly because this kind of image I already uploaded sometime. But in a case, this might take some time to upload. In your case, so all the steps done successfully means from my pipeline we are log into our registry, building the image into the runner, and we're pushing the image to our private GitLab registry in my own account, in my own project. So you go to your account, this is your account name, is account name, this is your project, in the project. If you go inside your, let me show here, go inside this kind of registry, and now if I refresh, last time I had no images, but if I refresh, you can see you will have one image come up with this name called third project. Okay, and inside the first project, if you see, this is the entire URL. Okay, entire URL. What do you write here? Exactly same thing gonna come up here. But if I click on this name, okay, now here we have the letters. These are the tags actually we have tags. Okay, and this is the detail of this image. Text we have. And now this image is stored in my my own personal registry or own private registry. Anybody, you can delete the tag, you can delete the image. Is different point. Anybody can download this image. Okay, anybody can download this image. Obviously, anybody means who know my login and password of this project specific password. Okay, and where the project specific password is stored? It's stored in the temporary variable. Dynamically, they create this variable for us. Okay, where when you run this line, this is going to create some temporary password. We can make it also give the permanent password of your account also. There's some more way we can give, but this is sometimes good practice to give this. Okay, so every time you run the job, that time the job or the pipeline has their own password. They use that password to log in, and then they will use this password. For building, we don't need any password because building is done in my runner node. But for pushing, we need the password. But one more thing I want to show you here is, okay, if I give a different name, let's say third project 1, 2, 3, and same I'm uploading here a different name. Let me see. Okay, so pipeline again start, and this job is building. So we are doing logging here. Logging has no issues because password is right. Building the job, you can give any name, doesn't matter. Your build image will done always. But if you try to give other name, it won't work. Access denied. Because they feel, okay, they feel that you are trying to go and upload the image into this project, not in this project, third project, in this project, and this project you don't have access to do. In my case, this project is not available in my account, or even though this project is available, but you can't access this project from this project because both the projects are independent project, and the password that you use here to log in, this password is temporary, but it's only applicable for this project only, current project only. Okay, so you can't change any name here. That's what I'm trying to tell you. Okay, so in your code, the syntax would be what they show you here, even though you can see not from here, maybe this initially they show you the syntax. Okay, even they give the commands also here for login, for building, and for pushing. Same syntax you have to use. You have to put inside your project name only. Okay, so this is one thing. Let me do some changes in my repository. Okay, and one more small change I want to show you here is if you try to write something like this, let's say my app, let's see. Till here, everything should be static. This is the one who tell you the URL of the GitHub centralized repository like Docker Hub. This will be account name and this will be project name. Till here, syntax will right, otherwise it won't work. Okay, after this, you try to something else as your image name. Let's see how it will work. Okay, so pipeline starts. So this build job is working. Again, the same step. They will log in. We're building. Okay, and after building, let's see how they push, right? But technically, finally, successfully, we have uploaded the image. That's what we have done. I'm just doing some small changes to do some checking and testing about the power and the permissions. Okay, now we're pushing this image in my same account, in my same project with a different name. In this case, it was successful, right? So my point here is what I'm trying to tell you, even though if you go inside the registry, what you will see inside your repository, you can see this is the image name. Okay, my app. And this is a multiple version, let's say latest. So a point here is in your project. Okay, in your project, if you want, let me edit. If you want image be stored with your naming way, you can write here. And that's what I want here. So I want my image to be stored in this format. So you can type this name in the last, over here, over here. Okay. So this is what the syntax I want to explain to you. Okay. So if you write this, this will work if you want to store the image locally in your runner. But we want to store this image in some centralized storage like Docker Hub or GitLab here, then image name would be anything. Image name, your version of the image was got tag, it would be anything. But before this, the name space means your account name or project name, plus the URL would be not anything. It depends upon where you log in and where you do the remaining part. Okay, even though guys here also we can use the variables. We can use the variable here. This project name also we can take from variable to make my code very dynamic. So same code we can copy paste here and there. You can find some more variable. You can give the project name, your account name, your registry URL. There's a different point. Okay, and now this part is done. Let me very quickly check. Now what you will see now when this pipeline run, this time pipeline has a 559. So your image will create with this name, with this tag or this version, and this image is going to push into your own private registry. So here in some time you will see here your image will put inside this registry. Here automatically come up, right? My app. And here we have one tag, one version. This one, 5.5. Here exactly same. It means every time I build, My image will store in this name only. Let me remove all this. I don't want the older one. We have a clean. This one also. And let me refresh the page. Oh, this one, right? So my image will store in this particular location in my centralized registry, but with different tags. Every time we build, different tags are going to come up. Okay. Let me very quickly build one more time, rerun, again rerun, and this time the job ID or the project ID may be different, maybe same, I don't know. So they will create one more tag here. Okay. Now, finally, what we have done successfully, we have successfully uploaded with the proper planning and management our current CI job image build and push into the centralized registry, that is per project based registry. And now image is there in the central registry. Now what can we do? We can write one CD job, continuous deployment job. And now we have one more runner. Okay, we have one more runner. Okay, and this runner will be a production runner. And what we'll do, okay, this job that I run the CD, one more job, belong to same pipeline. Okay, I asked this guy that get the image from here, it's called pull. Okay, and run this image as a container in the production environment. So my client from the internet, because you have the production system, you might have public IP, they can see this website. Okay, that's what the plan is. So I want to do two things. One is to pull, and second, I have to run the container. Where? In my production computer. Okay, and for this, what we have to do in my code, okay, what I have to do in my code, this job is running into my tags called my build. this job, guys, I want to run in my production system now. Again, this is the one of the tags we have, right? Very quickly, just to tell you, if I go to settings and CI/CD, one of the runner is already connected. Let me see very quickly. Is two runner running, and one of the running is running for the production. That's what I'm tagging here. Okay, tagging here. Now here, I want, okay, same thing happen here, but I want my image to be pulled. So I want to pull the image, we can run docker pull. And I want to pull from this URL. Copy and pull. In this system, I want to pull the image. And then maybe my older image or content already running. So let me remove it, and then we will run. For running, guys, you have to give the image name. So typically image name is this is the name actually of the image, right? Okay. So this URL is equals to image name. So to give you proper image name. Okay. So in the person computer, we will first pull the image, whatever created here, uploaded here, same image we are going to pull. Okay, then we are going to run the app. If app is there, we'll remove and create the new app. But process system need Docker runtime to be run there, right? So in my case right now in my production computer, okay, my Docker runtime is not set up. This computer, let me very quickly log into this format. The CD system means this computer or the server, and let me do very quickly the Docker setup. Because for pulling the Docker image or to run the Docker image, you need Docker runtime, right? So I don't have Docker there. This is a different computer altogether. Okay. Yeah, this system should be runner that runner installed initially in today's class, but the system should have Docker run. Okay, right now you see there's no images over here. and there's no container running here. And even though anybody who have the public IP of this computer, if you try to use this IP, there's no website running. But my intention is to run this website automatically with CI/CD. Okay. So now if I run this code, this code will going to run over here. Let's see. Okay, and something failed, both the things we will see. Now my job is running. Now there's two jobs. Now this job is running a different runner altogether. This job is running a different runner altogether. The job is to download the code app, create a Docker image, and upload into centralized repository. Okay, so this is what this job is doing. And now job is succeed, means everything they're done successfully. So if you go in the content registry, you will see now we have one more tag come up, means one more version of the image has been uploaded, and this version is actually just now is actually the same as your pipeline name 7328. If I go to my pipeline, this was the last pipeline we ran 7328. Okay, 7328. So this part is done. Second part, deployment is failed. Let's try to see why they fail. Multiple reasons it may be. Okay, but one of the reasons may be because of this Docker permissions. Okay, so they want to run the Docker command, but I told you guys Docker command run with the power of it will give the power, right, to run the Docker command, right? How to give the power, you guys know. We have same thing I run in my other computer also. So in my this computer, okay, which one? This computer, I have run the user mode. Okay, and in Intel guys, we are running this user in my runner, and I have to update my group to Docker. So this user has again the part of the Docker group. Okay, same thing I've run in my other computer also, right? So let me rerun my entire pipeline from its start, right? So even there's no requirement, the first job is run successfully. So better you can only rerun your second job. There's option there to rerun the second job, but let me start from everything from the start. Okay. And this time this pipeline is a new ID 680. So image will create with the same tag name. Okay, and we will push the same image and pull the same image in this deployment. So this will run successfully, obviously. This running is still, and because we run the job in the sequence, only after this job run, then the second job will start. That's what we need, right? Because the first job is the one going to build the image. Without building image, there's no meaning to start the second job. Otherwise, if you run the parallel, that's by default nature, second will fail. Okay, so still they're running this one successfully. Again, they fail. Let's see why they fail. So here they fail because of other reason. The other reason is pull. Okay, so this job has no power to pull the image. Okay, the job has no power to pull the image. Okay, everything work fine, but pulling they give access denied. Okay, they have no power to pull the image. Why? One of the reason is password is wrong. Okay, or one of the reason is we haven't logged in yet, I can say, because the way I explained to you, every job, okay, when you run, they will create a temporary password. They log in, and after job complete, they will remove that password, or they log out from the. I can say they log out from the login. So it means if you want to pull also, because this is a private registry, so push and pull you need to log in. So this is what we have to do one more time. Okay, one more time. And guys, this is a YAML file. You need to probably check the spaces, otherwise it will fail. Okay. So when you run this job, first they log in, whatever password they have for per pipeline or per job, they log in. And after the login, we can pull and all the things we can do it. Right. So they are running. Let's see what is happening. Okay. Otherwise, you can see there's a much more way to log in to the this container registry. One of the way this we can use. Otherwise, if we search how to log in to the GitLab container registry, so there's a multiple way. One of the ways called access token. Also, we can give a permanent token to somebody rather than we keep on generating the random password always. That's what the keyword do. Let's see. We can see here now they are logging to the system. After login, then do the remaining part on it. Okay. So this is one method. Otherwise, when you go for container and search, there will be multiple other ways to log in, and you can see there they show you one link of this page. Okay, and they show you here there's a multiple way to log in to the container. One of the ways called access token also you can use for login. Access again we create once and give to my team with some, we can control the power also, what power the access token can do. I'll show you very quickly how to use this also. Okay, so this is also one of the way to do. So the login successfully done. Now we are pulling the image pull is going on because it's a different computer. We are pulling first time in this computer. So last time guys, there was no image. Now in this computer, we are going to pull one image around 1 GB in size around. And then last time there's no container running. Now we launch one container successfully run. Now anybody who go to the system, there was no website, but now we can see the entire new website gonna come. Okay, working very, very fantastically. And if you see the pipeline, now we have a entire pipeline run successfully. All the stages run very much successfully. It means the way I started this today's class, it means my developer, if they work on their own local laptop, post the data, or they will do some change in the app directly there. Let me add it, or let me say welcome to Linux world by Vimal Naga, or maybe something like by all hello, something like this. Or maybe I put underline here. Okay, so as soon as I save entire pipeline they started, the by default nature of the Git lab is, as you see, change something in anything in the code repository, they will auto start your pipeline. We can change also. I'll show you maybe in next class. There's not a technical thing, but we can change also, and we can manually run the pipeline. We can write some conditions also when pipeline to be run, or we can schedule also. But right now, guys, in some time, this is a production system. You will see after you refresh, you will see the latest copy gonna come up. But right now, my developer changed something in the code. My CI pipeline will run. They will download the code. They're building the image into the different runner. That's called build runner. They're pushing the code into centralized container registry that is there in my per project base in the GitLab only. After put, then one more second job will run. This called CD job, continuous deployment job, or continuous delivery job. Okay, what they're doing, they're downloading the image to a different computer altogether. Okay, this is a person computer and they're running the container there. Everything is purely automated, right? Purely automated. As soon developer change something code, a code will automatically publish to release to my clients. And sometime when you refresh, you can see it's automatic as here. Right, everything is from one to one a technique called end-to-end automation. It's called end-to-end pipeline we have created. Now, between this pipeline, you can add multiple things. You can add staging area. You have more computer. You can do testing, test cases, unit test cases, integration testing. Multiple things you can write depend upon requirement to requirement, port quality checking, create a report. So 100 more things you can do upon your requirement. But as a core fundamental, this is the flow you guys can use for having end-to-end pipeline, everything automated. Okay, and that's what we have done here. Okay, otherwise, if you want, if you want that, if you don't want to use this way of login, this is a recommended way. Okay, if you don't want to have this login, there's much more way available for login over here. There's a better way I suggest to log in, but there was much more way available. You can also log in with the tokens, where you can give a limited power to token, that only token can read, only token can write. For example, in this case, I can use the token here where I want to give up upload power, write power. Here I create a token that will give a different power that can have only download power, read power. So those kind of customization also, that's called role-based control. We can do it. In my next class, I will talk about this point. Otherwise, there's some other way to give some limited power to something. Okay. So this code is we have created, and I will share this code to you. And a lot of the part of the GitLab guys explain to you. Some of the part won't take much time to explain, but I will continue this class tomorrow. I want to conclude this class today. So we'll continue tomorrow and we can build much more thing on the top of this. Okay. Even though I highly suggest, there's a lot of templates available here, I think over here, to see lots of different kind of examples. Okay. So a lot of templates available depend upon what you want to check. For example, Docker, GitLab, CI. So they're template available. So something like this I explain you here. Okay, and other things also, build and portion, all things you can you can see here. And you can add some scripts depending on the programming language. In this case, this may be cell scripting they're using here. Okay, so you can find lots of templates. It's a good way to learn the things. For example, one thing is that this template going to help me is before script. So these are some kind of code that before you run the script, if you want to do something, do it. So I'll explain this keywords maybe in tomorrow class, but this is a good resources in the learning. And if you want to integrate your GitLab with the Terraform, with AWS, and lots of use cases example, they have built over here. Different languages, different way to integrate, like maybe an example. So if you are in, or maybe let's say Node.js example. So this example we have, right? So we can use this image that I showed in my last class, Node.js image. Okay, and we are installing the node, running the node program, and something like this. Okay, so some example is good to start, and some example is very realistic use case example is a good resources. That's what I'm trying to tell you. You can edit this, change it, run it, all the things you can do from here. So that's all, guys, for today's class. One big setup we have done. I'll share this code to you, what we have built today. Okay, and that's all. Any quick queries if you have, we'll discuss. Otherwise, we'll see tomorrow with some more interesting concepts. Okay. Yes, Sudhanshu, we can create a GitLab project from command line also. They have a way. We have a command line utility available for the GitLab. We can create the project from there. We can run from there. I'll try to show you the demos, but answer yes, we can do it. Amit, you asked, I don't want that on every commit map I run. How can we? That's what I told you that in my tomorrow class, these are the small settings I will show you tomorrow that you can change according to your requirement. Is there any way only one particular job like we have any way to only one particular job. Papu, you can create one single job for this, right? Okay, you can create one single job for this. Why don't you run GitLab using Docker? Abhinav, we can run with the Docker also. There's a concept called Docker inside Docker. That's what by default, by default, um, um, Git shared resources do for us. They will run Docker inside Docker only, but we can also do it. We can also do it. That's we have to just launch a Docker, and inside the Docker we can run the runner. If you want, you can also take this example as a homework for testing. But very quick information. What if you're asking here is, so while launching the runner, we have a way to launch inside Docker. Okay, you can launch in the Kubernetes also instead of directly on the Linux. So here you can give the instruction. So we can launch a Docker, and inside the Docker, right, you can run the runner. Okay, so this is one command, Docker run, or this is some examples they give you. So there's an image you can use, or you can create your own image based on this. Even this is a command they give you. So this is one special image given by GitLab only. So this image has a capability to run the Docker, but inside this image, it becomes a container, and this container has a way that can work. This container will work as a runner platform. Inside this runner, we can do much more things. Even though we can build a Docker also inside Docker. You can try it. If facing an issue, just let me know. But this is also one interesting thing we can do. So you don't need any Linux or Windows system. All right. Just from the one Docker platform, you launch 10 different container, 10 different runner you can create. And every runner is doing something for you. Okay, just by typing this command. Or some other way we have, but this is one of the way, the simplest command we can do. Okay. So kindly show some Kubernetes deployment tomorrow. I'll try we can do it, but again, so simple. Again, instead of container, we can do on the pod in the Kubernetes. Okay. So again, if I show you, if you know Kubernetes, then we can launch a pod with some kind of specific image, and that pod can be so the Kubernetes can be running with pre-setup runners. Okay, so this is what we can do. So by saying here, they set up with the Helm chart that we're going to set up everything for us. But even though in the Kubernetes you can find there's a one pre-created image, you can run that image at the pod, and pod is running with the runner program. Okay, so this is some code example they give you. I'll try if I can show this demo, because technically demo is very simple. Nothing where 2 or 3 commands maybe can write. There's lots of extra things they write for extra management security, but setting up the Kubernetes cluster takes some time, right? So that is one reason only. Otherwise, setting up this part won't take much. I'll try my best to show you the demo in my next class of Kubernetes integration with GitLab for the runner. Okay, so can we run each job in several? That's what Jacob we have done, right? This is what we have done, right? Today example, that's exactly what we have done. Every job we run in separate runner, right? If you very quickly, if I show you my code, every job. So it's a one pipeline. Okay, one pipeline. The first job of the pipeline, I run a different runner. There's a tag we use. That's what the user tag. Second job, we run a different runner. This runner will be running Kubernetes. This running maybe run Docker. They're running with maybe Linux or Windows. You can use every job we can run in a different runners, right? I don't see so, Rohit. They ask you for the card. In my case, they doesn't ask me for card. Maybe you're not using a free version of the GitLab. Maybe you're trying to get the different version or the premium version of the GitLab. That's what they asking you the card. Just try to log in with the free version of the GitLab. Okay. GitLab integration with Git source tree. Sahil, there's lots of integrations we can do GitLab with. I'll show you tomorrow a long list and some of the quick idea of how to integrate GitLab with XYZ. It may be Git source tree and much more different tools. Okay, depending upon use case to use case, maybe console to some other things, right? So I'll try to give you a long list tomorrow. Depending upon, I'll give you the idea also. Then based on the use case, if it is there supported, or it is there some extra way to support, I'll show you multiple other examples. You can use that integration that I will discuss tomorrow, right? So that's all, guys. See you tomorrow and with some more powerful practicals and examples, right? I'll share this entire code to you and practice this. And tomorrow, guys, time will be a little bit different. My team will update you in your respective group, right? It's more be morning and afternoon time. So we'll update you soon. Bye. Take care and see you. Good day and good night.